Good morning. Welcome back to the EV Workplace Charging Virtual Workshop for the session called Understanding EV Site Assessments and Creating a Plan. As always, we are first going to share an EV testimonial video to kick off our session.
My name is Katie Maller, and I am the Business Development Representative for Indiana and the Marketing Coordinator with EV United. We provide custom solutions for both residential and commercial EV charging projects. According to EV growth volumes, we're seeing about a 40% growth in EV drivers every year. Today, I am here in Greenfield, and we are looking at putting in some DC fast charging stations into this parking lot. I think the mayor of Greenfield is interested in installing these EV charging stations because he envisions a Greenfield that will be sustainable for years to come.
My name is Chuck Fuel. I'm the mayor of Greenfield, Indiana. Today's market's going to call for more and more electric vehicles. We as a city would be behind if I don't have those charging stations in place. Across the street in another city parking lot, we have 2 charging stations there, right next door to a restaurant. So we use that, hoping that people can go in and stay around town, park their car, charge it, and shop while they're here. Driving in here, you didn't see any mountains, you didn't see any oceans. So we have to be very inventive of what we come up with to attract people to be in Greenfield.
EV drivers, they plan their trips according to where those charging stations are located. So let's say your town has an EV charging station within it and it shows up on their map. It will incentivize them to come to your town and use the charging station, but at the same time, they'll have that dwell time spent just checking out like different local restaurants, your park, your downtown area. It's a really great way to promote a little bit of tourism to your town. Now is a great time to look into EV charging just because of the incentives and grants that are becoming available to help incentivize your EV charging projects and help make them more affordable.
Well, I've always thought Greenfield was an example for other towns, but I also think that we have to be alert enough to say this is a new way of conducting business, a new way of attracting people, and we should be on the forefront.
I love those videos. And I love hearing the stories going on in Indiana with electric vehicles. Again, you can find those videos on the Whova platform, and it's usually under a title called Subsessions. Now for the first half of today's session, we will hear again from our friend Jesse Bennett, research engineer at NREL, about site planning requirements. And then for the second half of the session, Jesse will help you go through a plan, or customizing a plan using a flowchart and worksheets. If you are looking for those worksheets, they are located on the Whova platform under resources. So you can go ahead and download those and be ready to kind of walk through your own worksheet if you want. And that will be more of the interactive part of this session. All attendees should be muted and have webcams off for the first part of the session. And then following the presentation, we encourage you to use your webcams for a more interactive experience. So now I will pass things over to Jesse for his video.
All right, good morning, everyone. Well, I'm glad you're able to join me, and I'd like to discuss today a little bit about EV site assessment. My name is Jesse Bennett. I work for the National Renewable Energy Lab, and I do a lot of work supporting the FEMFLEET program and fleet electrification for the federal government. And in this experience, I have a couple of EV site assessments that I've gone through that I think are really key in helping people plan for EV infrastructure and EVSE adoption. So as you're switching over some of your fleets or potentially municipalities, a lot of people are purchasing EVs in your area, they have the need for EVSE. I'll step through the process and kind of my thought process of how to plan for the installation of these new devices. And really, what is the most important process needed to make sure that these devices are installed correctly and in a way that's useful for everyone. And I've broken this down to what I think is 5 high-level sort of categories. I think obviously the first step is to consider vehicles. I know for fleets, there's a lot of different options here. Some fleets might consider low-speed electric vehicles. I think plug-in hybrid electric vehicles are a great transition tool that offer the ability for electric vehicle technology with the benefits of a backup generator, sometimes some combustion engine that can help you in longer trips where batteries might have some limitations. And then there's also battery electric vehicles, which have increasingly greater ranges as every year as new vehicles come out. And I know that even some larger options like trucks and SUVs are definitely on the horizon. So first step is to consider the vehicles that will need to use these EVSE stations or electric vehicle supply equipment. And really, what are the energy needs of these vehicles? So how long will they be charging based on their dwell period and energy requirements and travel needs? And that will really fuel what type of EVSE you need to install. So looking at type and quantity of EVSE, you have a couple different lower speed, like a level 1 charger, as well as a level 2 that's maybe a little more high powerful. And then you have the SAE, the combined charging standard, which is the DC fast charging option, as well as the CHAdeMO versions. And both of these are very high powerful chargers that would be a bit more expensive to install, but also offer the end user a much faster recharge time. So it's definitely a cost benefit analysis here, looking at what is the need for these vehicles versus what your facility or agency can afford to install. But once that's sort of determined, the next step is to analyze the local facility and what sort of upgrades might be necessary, looking at the service panel, potential installation of new service breakers, as well as any other equipment that might be needed to service that those needs of these vehicles. Once that's sort of determined then, and you understand, well, these are the vehicles, this is the EVSE I need to install, and here's the upgrades that are essential in my facility to kind of support that infrastructure, you need to also contact the utility. Especially if you're going to be upgrading some of your service infrastructure, they may need to look on their end as well to make sure something along the lines of a transformer, maybe a main line, and that need to be upgraded, things along those lines. It's important to contact them when you're installing this new equipment. And then the final step is obviously construction. So installing this new infrastructure, these new chargers, such as circuit breakers, the conduit, conductors and wires, and then the EVSEs themselves. So going through the site assessment, we have a couple different requirements that come through various entities. The first of which is actually the requirement that each new EVSE unit be installed according to NEC 625. So that's the National Electric Code, and it outlines how these new charging stations should be installed. One of the most important things is that overprotection, or say the circuit breaker, must be sized for 125% of the maximum EVSE load. This circuit breaker must also be servicing a dedicated circuit. So for every branch circuit you have in your home, such as say for instance for the kitchen or a certain bedroom where the circuit breaker will turn off all the lights in that area, you need to have a branch circuit that's separate for that, individual for each EVSE. Then you need to also look at panel capacity, and most specifically looking at the spare breaker positions available. So look at the picture on the right-hand side here. Each of those rectangles that is available below the circuit breakers that are previously installed is referred to as a breaker position. So the number of breaker positions available is really important in terms of planning how many EVSE you can install with your current infrastructure. Now, in addition to that, you have at the top the main breaker rating, which protects all of these circuits below. That's a separate rating that must be sized to meet the peak coincident demand of all your devices. So what is the highest load that might be coming through your facility and demand at any given time? And the electrician installing these circuit breakers can help you with that, but it's important to consider that this may also require an upgrade. And if this happens to need upgraded, say you're installing quite a lot of EVSE and your main breaker needs to be upgraded, then you might also need to start talking to your utility company. And this is where there's the potential that your service might need to be upgraded because you could potentially be requiring a lot of more energy. than they're used to supplying you. So they will have to look at things like transformer capacity to make sure that it can properly serve the needs of your new equipment. Now, for this new equipment, just some high-level requirements for the J1772, that's the SAE standard. There's a typical AC level 1 and AC level 2 charging types that I think you might be familiar with. In terms of their requirements for the previous section that we covered, the single 20 amp breaker is a common requirement for an AC level 1 unit. And that's primarily because they typically supply about 1.9 kilowatts to the vehicle at 120 volts. So that's a standard single leg of the 120 volt service coming into a home or even a facility. And they sort of require 16 amps. So as I mentioned before, you need that 125% buffer there. 16 amps times 1.25 gets you that 20 amp breaker. And it only needs a single breaker position because you're only pulling one leg of that 120 volt service. Contrary to that, the level 2 standard actually is open to a couple different types of service options. Most common with residential homes, you have 120 volt or 240 volt services. 240 volt is most commonly associated with your air conditioning units, sometimes your dryer units, and it's those more sophisticated sockets that actually have 4 prongs typically instead of just 3. And that 240 volt service actually requires a double pole breaker because you're pulling in 2 legs of that 120 volt service there. And they're commonly for 240 volt 7.7 kilowatt units, which means that they require about 32 amps. So that 32 amps, again, if you make sure you have that NEC breaker protection there with the overcurrent buffer of 125%, that gets you to about a 40 amp rating on the breaker. And that's where you need actually a double pole breaker to protect 40 amps for these units. And the same can be said for a 208 volt service. It's very common in commercial applications. It also requires a double pole 40 amp breaker. So just to summarize things, if you're installing a quick, small little level 1, you only need a single breaker position and a 20 amp breaker, whereas level 2 actually, it's about twice that typically. It's most common where you require a double pole, so 2 breaker positions, and you'll need a 40 amp rating typically for those units. But in terms of planning for site assessments, I really think the best approach is to kind of just walk you through a couple examples that I've done over the past years. And I've highlighted 2 different site assessments here that detail from a fleet's perspective. They were considering adopting electric vehicles and trading out some of their older fleet options for some newer electric vehicle options here. And for the first example, we have a fleet that has currently 5 light duty vehicles they're looking to replace, and they're operating about 5 days a week, typical 9 to 5 schedule, and they travel an average about 50 miles a day. So nothing too far, but the challenge here is they actually sometimes take occasional longer trips, and they actually have an unpredictable schedule because of this. So sometimes they're parked in different locations, and they're not always parked at the same time of the day. And also because of all this travel, all-wheel drive is preferred because they may encounter inclement weather. I think the optimum option here for them was a plug-in hybrid electric vehicle, as they're still sort of working on how best to adopt electric vehicles in their fleet. They were a little unsure about the longer trips. They wanted to make sure that they could fill up a gas station as a reserve if needed, but they could still make great benefits from the electric vehicle drivetrain. As you can see here, the Mitsubishi Outlander plug-in hybrid electric vehicle actually has a range of 22 miles. So the majority of their driving every day could be covered in all-electric mode, with the remainder of the range of the vehicle, up to 310 miles, operating in what is referred to as a hybrid mode. So it's still a very efficient use of gasoline, and it does provide them the option of an all-wheel drive SUV vehicle. I also, for a lot of these slides I have on the bottom here, a design note, and this is sort of just a little side note here that will discuss a few key elements of covering a broad range of topics for site assessment I think are important. In this case, the Mitsubishi Outlander actually has a smaller battery than most battery electric vehicles because it's just a plug-in hybrid, and it's therefore also limited in the charging rate that it can receive. So not only are you limited by what EVSE you install, but the vehicle is also limited by an onboard charger for when you're talking about AC charging. This vehicle can only receive a maximum of 3.6 kilowatts. Now you might notice that's still much greater than the maximum level 1 unit, so it's still a huge value for them to install level 2 stations, as well as the thought that in the future they'll probably be purchasing battery electric vehicles, and it'll be great for those vehicles to take full advantage of this charging level. And this onboard charger in all these vehicles varies between manufacturers. So it's important to consider not only what the EVSE can supply the vehicle, but also what the vehicle can receive. So for the next step, after you've determined certain EVSE is required, you might want to think about where is this service going to be coming from? Where is the energy supplied from the utility, and what sort of upgrades might be necessary? And the first step in that is actually highlighting the lines that the utility services come in from. So we have here highlighted in red the different service drops from the transformer you can see off in the distance in the back of that right photo here. And what we actually notice is there's two different service drops going to the building in question, and that's the lower of the two on the picture on the left-hand side. So what we can deduce from that is most likely there will actually be two service panels inside the building. And we did notice that there was a 37.5 kVA transformer cluster mount. So there's three different transformers up there, all rated at 37.5 kVA. It's something we can discuss with the utility companies if that happens to come up later on. But really, when we go inside, we do notice that thankfully there's actually 6 parking spots. So more space, or actually, I'm sorry, 8 parking spots. So more than we require for these new electric vehicles. They could easily be stored in this garage. And there actually are 2 different service panels here. We have highlighted in the bottom right, you can see here, there's a 150 amp lighting load circuit. So all of the lights and everything in this building are actually powered from this 150 amp lighting circuit. We also have a 225 amp circuit that powers the actual car wash in the back of the garage. So as vehicles exit, there's a car wash that can be used if necessary, and there's a separate circuit designed just to power that device. Both of these circuits also operate on a 120 240 volt service. So if you remember back from the previous slide, that's actually provides a benefit because we get a slightly more powerful output from a level 2 station with that 240 volts as opposed to just 208. And something just to note here, the design note on the bottom, service panels have an enclosure rating which is separate from and should be greater than or equal to the main breaker rating. So as I mentioned before, if we're upgrading main breakers as a result of installation of new circuit breakers, something else you might need to consider when you have an electrician coming in installing that is that there's a chance that you may also have to require a new service panel upgrade. And the benefit of that is also you would potentially get more breaker positions as well. So you'd have more space for future capacity in the event that's needed. And then, as I mentioned, we need some EVSE installed to supply these new vehicles with energy. And something I like to always recommend is it's much more affordable for different facilities to be installing dual port units. So that's one EVSE unit that actually has the functionality of 2 different charging capabilities. So it's sort of 2 EVSE units packaged into one with 2 separate charging ports. They're a bit more economical in terms of a per port cost. So assuming you're installing at least more than one EVSE, it's most likely economical to look at a dual port unit. We also looked at wall mount units because wall mounts, as opposed to a pedestal style, you might be common with a lot of along the highway type of charging, such as like at rest stops or gas stations. Those type of chargers are slightly more expensive to begin with in terms of their unit cost, but their installation costs are also a little bit higher because they require additional trenching and things of that nature. So what we recommended was 3 level 2 dual port units. And that'll actually get us a total of about 46.2 kilowatts of new load. That's something we can share with the utilities. Just a basic calculation of voltage times current, or if you happen to know the power rating of each of these devices, which is probably something along the lines of 7.6 kilowatts, then you can just multiply that by the number of ports that you'll be installing here. Something to consider going forward. However, we did notice that this was quite a bit of electricity that we'll be consuming, and looking at both of those circuits, they were actually already quite full and quite at capacity. So what we needed to do was consider expanding one of the service panels. What we did was we're expanding one of the services to actually a 400 amp service panel that will then separately feed the 150 amp lighting load we have here on the top right. Then we'll also be installing a separate service panel that will be servicing these new 3 dual port EVSE units. about 240 amp rating is probably a good bet here, and that'll serve the 192 amps that the 6 EVSE will require, and that's just a basic 6 times 32 there to get the total amperage rating there. Something else to consider, because we're upgrading this circuit, we'll need to look at the main breaker rating. And as I mentioned before, the sum of all branch circuits may exceed the main breaker rating. However, if the coincident peak includes each load, it may cause nuisance tripping. And essentially what that just means is just because you have 10 different 20 amp circuits doesn't mean that your main breaker needs to be rated to supply all of those loads, because they most likely won't be on at any given time. However, that is the most conservative approach. And if you do maybe are a little bit more conservative and you have a bit smaller main breaker rating, then what's going to happen is this nuisance tripping, where if too many lights or too many devices are turned on, your main breaker will trip open and turn off the devices. That's another great question to talk with your electrician to kind of just have a pros and cons on what is the best sizing for all of these circuits. Then after that, you want to look at, if we're upgrading the service panel, how do we get this electricity from the new service panel to the location needed for each of these EVSE? And as I mentioned, we're installing wall mount units, so we thankfully won't be requiring any trenching, but it is important to note that trenching is a rather expensive cost, and it can be one of the most expensive costs of an EVSE installation. Some estimates can be around $100 per foot or more, potentially upwards of $150 per foot, just to trench out to the EVSE. That doesn't even include the costs of conduit and wiring, as well as the EVSE unit itself. So it's definitely important to scope out how far all of this conduit will need to go and how much wire you'll be requiring. But thankfully, trenching costs in this instance won't be too much of a concern, because we have wall mount units where that won't be an issue. We have it outplanned here, though. We have about 150 feet of conduit that will be required, and 150 feet or so of different wiring, most likely a 3-wire system, that will be going to each of these EVSE units. So for the second site assessment, we had a similar issue here, where we had 6 light duty vehicles, but they were operated 6 days a week, the typical 9 to 5 option here, and their average daily travel was actually a bit more, about 100 miles. They did go on the occasional longer trip, but it wasn't too much of a concern for them. They were in an area where they were pretty confident the public EVSE infrastructure could suit their needs in terms of a midday charging event. And they also had the luxury of consistent parking locations. So most of these vehicles would be parked in the same location all the time. That creates a great opportunity for the battery electric vehicle. So quite a lot of travel throughout the year, with 100 miles a day on average. And it actually helps you to pay back the potentially higher cost of the electric vehicles that might be associated with the battery, because the more miles you get driving, then the more savings you actually get, because you're saving on that energy cost and operation and maintenance as well. So the Chevrolet Bolt BEV offers a great option as a light-duty subcompact sedan, and the Bolt's 60 kilowatt-hour battery can be recharged in approximately 8 hours with a level 2 EVSE. As I mentioned before, this is also limited by the onboard charger, about 7.2 kilowatts. But you can see here, even 7.2 kilowatts, you're getting that full 60 kilowatt-hour battery, which can take you about over 300 miles, can fully recharge it in less than 8 hours. So therefore, even if they happen to have an incredibly long travel day, they came back and had an 8-hour dwell period overnight while most of their employees went home, then they could fully recharge the vehicle without much of a concern. This location actually had 2 different building options here. We were looking at 2 different candidates for where these vehicles would be charged, where they would park and stay permanently. And building 2.1, for instance, had a 1500 kVA transformer servicing them, and they required a 208Y 120 volt 3-phase service throughout the building. So commercial application, commercial voltage here. But one thing to note at the bottom right here, the setup for this particular facility was that they had to still own a portion of their transformers. As I mentioned before, some facilities own their transformers while the utility owns them in most cases. In this case, actually, the utility provides them a 480 volt service from their distribution transformer. And then the facility, then what they do is they have a step-down transformer that goes from about 480 volts down to their typical industrial voltage 208Y 120 volt 3-phase service. So The other challenge here, though, is as you can see, the transformer on the right is outside of this parking area where the building is on the interior of the parking structure. So all the service panels will be inside of that building. So it's important to consider if you're installing a new electric service, that may be a better option than, say, for instance, trenching underground. As you can see, most of these vehicles are parked on the outside perimeter of the parking structure. So to supply some EVSE to these locations, we may have to do some trenching, and it's something important to consider. However, installing a new electric service may be cheaper than using existing infrastructure, particularly when the service panel is located far from the potential EVSE site. So in this case, there's the potential that looking at a new service from this distribution transformer may actually be a better approach for this facility. However, we'll take a look at building 2 real quick first to see if that's a better candidate. And they actually had a much smaller transformer building too. It's a smaller building in general, and a 300 kVA transformer rating there also supplies this 480 volt service that then the facility must install a step-down transformer to operate at their 208 volt service. And here we go, as I mentioned before, some 3-phase services are provided a 480 volt service. In these circumstances, a step-down transformer is required to supply the standard service. And we have a similar line diagram here where the utility distribution lines service that 40 volt distribution transformer that then must be stepped down again by a facility transformer to 280 volts, at which point then you have the service panel and secondary loads. So for this, we had a similar recommendation. We had the 3 level 2 dual port units as in the prior case. It's a very common approach to fleet installations as well as some many common public stations as well. Unless you're along a highway, it doesn't seem that there's really a need for a DC fast charger. I think a level 2 does a great job for a lot of charging needs. In this case, we also recommended installing dual port units that were actually, in this case, pedestal units because there weren't any walls nearby to install wall mount units. So what we do is we're required to install a pedestal unit, but there's a few other installation costs associated with that, such as trenching and a concrete service are required. And that's because for these pedestal units, the wiring actually comes in from underneath the devices. So you have to have a concrete pedestal unit to support that EVSE. And then you have to have the wiring coming from underneath. So trenching, at least a small amount, is required in this instance. So we're looking here at which of these 2 is the most is the best candidate for EVSE installation. We have building 2.1. We have a large utility transformer. Most likely, it has a bit more capacity in there, especially enough capacity to serve this new EVSE. And thankfully, the highlighted location here where we install these transformers, there's some parking right along this the edge of the parking perimeter here, where we could install some EVSE stations to serve these new vehicles. Minimal trenching is required because if we do install a new service right next to the station, as opposed to trenching underneath the parking structure from building 2.1 to pull off the existing service panel, then we're not going to have as much of a trenching cost. And that's just sort of what this design note says here. We're locating EVSE close to the utility point of interconnection. So that's sort of where the last piece of utility equipment meets the first piece of facility equipment. Not only saves on trenching, but also limits the length of conduit and wire needed. And we'll really see that come into play with this second building, 2.2, where a smaller transformer capacity of about 300 kVA is potentially at greater risk of requiring an upgrade from the utilities perspective. And you also look here, the only parking locations that were available in this certain facility were actually a little bit farther away from where the transformer was. So if we're still going along that route of installing a new electric service, then we're going to need a little bit extra trenching, probably about an extra 100 feet required. And this is just something where you want to make sure that you're avoiding this at all costs because it is one of the most expensive elements associated with the EVSE installation. So it looks like, based on a couple of analysis, that building 2.1 is probably a better candidate. And then just from a high-level summary, site assessment example 2, we have here, we'll have a distribution transformer load analysis that the utility will look through. And we're going to be expanding that new service. So that 3-phase 480 volt distribution transformer will have a new service coming off of it. And you might have noticed a couple of slides ago that we actually still recommend a 240 volt service for these EVSE. So looking at maybe a 120, 240 volt step down transformer, and that's to really get the maximum amount of power out of those EVSE units. So you can supply them with that 240 volts as opposed to 208. And this is where you can see here, this new service that we're looking at, building 2.1, will require a small amount of conduit raceway, so about 50 feet of trenching and conduit. They'll still require some concrete pad installations, and then a sub-meter and service panel to kind of install those circuit breakers and protection requirements. But it'll be a little bit separate from the facility load, so it'll be a simpler installation, minimum trenching, and a better approach for them long term. Something else you can look here is we actually recommend a new 400 amp service panel with 12 double pole 40 amp breakers, or at least the capacity for that many, because this facility in particular was looking at potential future growth. So they had even additional parking spaces below the previous image that we had highlighted there, where they could plan on installing new EVSE. And right now, because they're going through the trenching costs and the upgrade requirements, it's best to plan for the future. They most likely don't need to install all of the EVSE units, but at least ensuring that you have the spare capacity, and potentially even installing something like the conduit stub out and different wiring options that would make that installation easy in the future is a great approach. Really saves on the total construction costs in the long term if you kind of think ahead a little bit. And so that was all I had here. There's a couple site assessment summaries here where it just steps to the process. I know here in a little bit, I think we're going to go through a worksheet that we've developed that outlines this process as well, so you can go through a similar approach and talk about some of the different steps that you might have challenges for. But if you have any questions along this presentation or anything else about fleet electrification, please feel free to contact me at the email here at nrel.gov. Be happy to answer any of your questions, and I think we have about 30 minutes or so after this to kind of go through that worksheet and talk about the best approach for maybe your fleet or your agency or municipality's approach to fleet electrification or EVSE installation.
All right. So hopefully you guys took copious notes. I'm just kidding. You can go back and check the recordings later. Fantastic information as always from Jesse on EV site assessments. As a reminder to our attendees, for the second half of this session, please turn on your webcam so we can have an interactive discussion. For questions, we recommend using the raise your hand feature on the Zoom menu. If you're not sure where that is, you can find that if you click on participants at the bottom of your screen. And then there's a little box that pops up, and you can click on raise your hand, and that will kind of help shift through the conversation if there's a couple people wanting to jump in and ask some questions. So we definitely do want it to be interactive, and if that for whatever reason isn't working for you, just go ahead and do this, or just wave your hand, and we'll make sure that you're ready and you can ask your question. And when you do start to speak, make sure you're unmuted, because we won't be able to answer your question if we can't hear you. So now Jesse will start off discussing the worksheets and the planning process, and then our hope is that our attendees that have questions or need a little bit more guidance can go ahead and ask their questions. And so Jesse, I think you can share your screen if you want to.
Great, yeah, thank you. And yeah, I'm sure that you're probably all tired of hearing my voice now after that long presentation. So I really want to kind of go into the interactive session portion of this. And I want to hear maybe after you've kind of gone through some of the basics of planning for EVSE installation, what are your questions? And if all of you have been able to kind of download that worksheet, there is a workflow at the top there that talks about 4 different high-level points, and those are kind of the main topics I wanted to touch on here today in terms of the EVSE needs, power requirements, the necessary equipment, and then the construction plan. But I definitely want to just start off with the EVSE needs and see if there's any questions that people have in terms of planning for this. If you have questions around how do I decide between level 1 or level 2, which type is the best, I definitely want to open up the floor to any questions or concerns people might have on this portion of the process. And I do have actually, if there are, just to kind of guide you along, I'll show some examples of kind of the steps that I thought through in my thought process, at least for this step. I'll use in a little bit of the example, I think it was example 1 from the previous presentation, but you're looking at sort of, if you have a facility highlighted or picked out, then you might want to look at how many vehicles you have and how long they're driving per day. And you might say, oh, well, looking at the kind of tips on the right-hand side, you got AC level 1 gets them about 5 miles of range per 1 hour of charge. So that means each vehicle will need about a 10-hour charge at level 1. Well, that's not going to really work very well if they need a shorter turnaround period. If, say, maybe a 10-hour gap is too short for your employees, maybe you need something a little faster, like in AC level 2. It's a very ideal for fleet situations, but it's open up to every situation, and depends on how much you're driving per day and what your vehicle dwell time is like. But and then you might think that, well, it looks like level 2 dual ports work well for me, and that's kind of how I thought through this process. But I know that there are probably definitely some other opportunities out there for like AC level 1 opportunities or DC fast charging that might be more ideal.
As a reminder to the attendees, you can go ahead and turn on your webcam. Our hope is to make this a little bit more interactive, so we're not always talking at you, and we can walk through this with you. So if you are planning a project or you ran into a couple issues, or you're trying to figure something out, now is a very good time to ask those questions.
Yeah, it's funny you mentioned about the making sure that you're unmuted before you speak as well. I never thought up until the last year or so that there would actually be a mute button in real life. And that's something you sometimes dream about beforehand, but there is actually a mute button now. I need to make sure that if you're speaking, make sure you unmute yourself.
Yes, yeah. If only there was a mute button for everything in life, but yeah. All right. So I do know we have a few people who are attending that are with municipalities, and you guys are welcome to talk about, if you want to jump in and talk about how you've been doing your planning process. We're happy to hear from you. Again, someone who is considering it or trying to navigate this process, this is a very good time to look at this worksheet and sort of go through that with Jesse while he's with us. Jesse, maybe you want to go on to the next part of that worksheet.
Sure. Yeah. Maybe I'll just make it one or two more comments. I know a lot of people always feel tempted to install the highest power DC fast charging stations because you see that very nice and tempting 100 miles per 1 hour of charge. But as mentioned earlier on today, there are much more drastic considerations required for DC fast charging with the higher power requirements, looking at like potential impacts on the utility. So that's where utility incorporation work comes into play a little bit more, maybe upgrades in their system as well as yours. And it's usually more than you would typically require. As you can see here, 50 miles of driving per day can get you a full charge in just about 2 hours on a typical level 2. So that's like especially for fleet applications or even workplace charging, those are both great opportunities. They might be tempting more in a public environment if you're building out something for, say, a quick mini mart or something like that, or a quick grocery store stop. You want to make sure people get a full charge potentially in a short amount of time. That might be an opportunity, but I think DC fast charging is best suited for sort of highway travel more often than not. Mm-hmm. But if once you've sort of decided what EVSE you want to go through, if you've highlighted what your needs are, you need to also look at the power requirements. So looking at voltage considerations and how much power each of those units are going to conserve, and what is the new load essentially going to look like. And it's pretty simple, as I mentioned before, but just look at your overall service interconnection, see what the service and service panels look like. Realize, I'm receiving 12240 volts, like a typical residential location. Then you know that sort of then limits what your voltage you're going to use if you're using a level 2. And that then dictates if level 2, that's 32 amp system is pretty common for a lot of EVSE. As we mentioned, the sort of a 40 amp breaker sizing is very common. You're going to get about 7.7 kilowatts. And then you just size that up, looking at your total peak power. At the worst case scenario, if all of them are plugged in, then you'll get about a little over 45 kilowatts at peak. So that's like something you can communicate with your utility company if that comes to play. You'll talk about installing all these new stations, and the worst case, this is the new load and what it might look like.
I don't have anyone. I did want to comment though, Jesse, when you were talking about, everyone wants that higher power, the fast charger, right? Because they don't want to spend a ton of time on trying to refuel their car. And I will tell you that a lot of people got kind of pushed that way based on sort of the funding opportunities that were available as well. So, the Volkswagen has been huge, right? And Jordan mentioned that is what prompted a lot of his engagement with their customers and stakeholders. And the majority of the funding was going to DC fast charging, which we know that is more expensive. It's a a much more involved type of project. And so we did have some municipalities and other stakeholders looking into this because that's where most of the funding was available. And they were also trying to fit all the requirements that came out or was released through IDEM, Indiana Department of Environmental Management. So, I mean, all the more reason for you to go over these things, but understand that some of them, they are looking at the DC fast charging because that was something that was wanted from the funding or the grant opportunity.
Yeah, and I mean, DC fast charging has great opportunities, and it's really potentially convenient for people in a lot of applications, especially like long distance travel, or even if you're looking at maybe a municipality building out your public stations at, say, a grocery store, something like that. People maybe will require about 50 miles of range, like we showed before, and that could, the 2-hour charge time to get that miles of range is maybe too long for a grocery store stop. And DC fast charging is a great opportunity. And one of the reasons that I kind of tell people to shy away a little bit from that is, if possible, is because of the infrastructure investment required. But if there are programs that are kind of supporting that element, I believe the Volkswagen settlement's a little different in every state, but at most places they do provide more funding for DC fast charging stations, which makes sense. They're more expensive, and they're also more expensive to install from like an equipment perspective as well, like circuit breakers and wiring usually require some more upgrades. Those sort of requirements, or maybe if the benefits outweigh the challenges, then yeah, it's definitely a great opportunity. And I mainly just don't want people to look for DC fast charging, then realize, oh my gosh, this is very expensive to install.
Right. We do have a couple hands up now. So Sean, I think I'm going to click over to you first if you want to turn on your webcam as well, so we can see you when you're talking, and make sure you're unmuted.
I cannot turn on my webcam because it says that it's been turned off by the host. So I will just go ahead and ask my question. My understanding is that
yeah, we can do that.
Here we go.
I'm working on it.
All right. All right.
You can go. There we go.
So my question is, I understand that not every vehicle that is out in the market today is able to be charged with a DC fast charger. So how much of a issue is this going to be because of the high cost of installing a DC fast charger compared to the fewer number of electric vehicles that can actually utilize them?
Yeah, that's actually a great question. I appreciate you for bringing that up. I hadn't thought of that, mainly because, so in my experience, the electric vehicles that you're speaking of that kind of don't have a DC fast charging option, it's more often than not that they are plug-in hybrid electric vehicles. So the types of vehicles that have both the ability to run off of gasoline as well as electricity, and then they can operate in a hybrid mode as well. And the reason they don't typically have DC fast charging, with the exception of the Mitsubishi Outlander and maybe a few others, is because they have such a small battery. It isn't really worth the effort to provide that ability, because the recharge times on the batteries, even if they're completely depleted, are so quick, even on a level 2. And that's primarily because they are only get about like anywhere from 20 to 50 miles of electric range before then they start to operate in the hybrid mode. So it's more of a transition technology, or it works great with people that have short commutes and then have the occasional longer trip. But I do think in the long term, all battery electric vehicles, and I will have the ability for DC fast charging. Now, then the question comes up, you might be considering about looking at the SAE standard versus the CHAdeMO standard. So I know that the CHAdeMO standard, I believe it's an Asian, more common with Asian manufacturing companies, such as the Nissan Leaf, I know is a very common one. The way that the Nissan Leaf actually charges, they have the SAE standard for AC charging, and then the CHAdeMO just for DC charging. And then say, for instance, the Bolt, it has the SAE standard for AC charging, and then it has that expanded port that's SAE standard as well for DC charging. So really it comes down to there's two different major technologies in the US that offer DC fast charging, but thankfully, as we've been talking about the Volkswagen settlement and a lot of other DC fast charging build out, most of those stations actually provide the option for either ports. So both the CHAdeMO and SAE CCS standards are available on most ports. So having the option for both is very, very common, and it's something that's being used more often going forward. So I guess the short answer would be, I think most of the concern without DC fast charging is plug-in hybrids, which I don't know if that will be a technology that's more of a transition. It might not be the case long-term, but most battery electrics will have DC fast charging capabilities. And in terms of which standard option is available, most public chargers have both available.
Thank you.
It looks like we have, maybe we'll have Kevin go ahead and talk, ask his question, and then we can continue on with the worksheet. That sounds good to you?
Sure.
All right, can you guys hear me? Can you hear me?
It's a little muffled.
I don't know where my mic is anywhere. I'll sit closer to my laptop.
It's better now.
Okay, maybe it's on my
Now that you-
laptop. My laptop's docked into my computer. So my question is, so I just finished my grant application for IDEM, and most of the garages, so we're looking at 3 different garages to put EV chargers in. There was immense amount of capacity. They're all brand new garages, right? You know, the last 2 to 3 years. So with that said, I wasn't worried about space within the panels, but this is quite, the question's really directed at Pete. I mean, I doubt that all 4 chargers in one garage will be plugged in at the same time, but I shouldn't have to worry about notifying the energy provider on something that small, should I?
So let me think there. You're adding new stations, but you have a lot of capacity in the service panels, so you're sort of expanding.
Right, and so I don't even know if that's relevant when I say that. I mean, right, just because there's tons of capacity in the service panels, does that mean there's also tons of electrical capacity in the garage as well?
Yeah, so that's a great question. When your electrician's installing the service panel, everyone might be familiar with sort of the main breaker at the top and then all the small little breakers below. The main breaker is what protects overcurrent protection for the entire line coming in. So the total of all of the loads coming out of all those under circuits. And then each of the smaller breakers, they protect each of those branch circuits that go off in either direction throughout the garage. So if your garage is installed with a lot of extra capacity, say for instance there's a lot of spare breaker panel spots, breaker positions, then you could work with an electrician to have them installed. And then really what would happen is if you're installing so many that you actually need to upgrade the main breaker, that is the point when you might need to begin talking with your utility company, because the main breaker is really what your service lines coming in off the transformer, they'll be more concerned with what is your main breaker, because that's the worst case scenario. So if you're thinking about a big 150 amp at the top, then the utility company probably only thinks of your house as like, all right, the worst case there is 150 amps. That's all, we don't need to worry about it ever getting higher. So then if you need to expand, say, if you increase the load such that if all the EVSE are on at one time, it goes beyond 150 amps, then most likely your electrician is going to recommend upgrading the service panel or potentially having 2. And at that point, that's when you'll need to work with your utility company and talk to them about the new increased load.
All right. Yeah, so our panels are 400 amp in both garages, all 3 garages actually. So and we weren't pulling anywhere near that. And I did have an electrician, everybody actually is part of this. I'm sure it was all going on in his head. He just didn't say anything to me, right? Does that make sense? But now that I've listened to you, I'm like, oh, that's super interesting. I wonder. All right, thanks.
Yeah, no problem. So yeah, and if you are going to upgrade your service panel, I think one of the best metrics to share with the utility company. Obviously, the electrician will share the new breaker panel, but you might want to share with them as well this metric here, the 46.2 kilowatts, or just talk about sort of how that load is increasing and why it's the potential to exceed their current capabilities. So going to the next step, then talking about necessary equipment. Once we've determined sort of that peak power, we talked a little bit about this, but what are the necessary equipment upgrades? And this is really getting into that branch circuit design. And as we mentioned, each new EVSE needs to have its own branch circuit. We did touch on this a little bit, but there are some potential questions that could come up. I know if you look at the SAE standard, level 2 is actually able to demand an 80 amp maximum. So technically, according to the standard, the maximum power that could go to, or current that could go to a level 2 station is actually 80 amps and not 32, which is most common. But as I mentioned, sort of the 32 amp is very practical because 40 amp circuit breakers are very common and simpler, very common to install and easier for sizing, like the service panel, like we were just discussing. And then the biggest consideration here is, like we mentioned, making sure that you have sufficient breaker capacity and service panel capacity for all the breaker positions you require. But are there any additional questions? I know we touched on this a little bit, and I know that from sort of the example before, if you're looking at, say, 6 ports, you potentially need 6 new branch circuits because you're having to install 6 new EVSE. So this is something maybe that wasn't initially clear, was if you're, say, installing a dual port EVSE, according to the National Electric Code, you should technically have 2 separate branch circuits powering those. Now, some EVSE actually provide the opportunity for power sharing, so you only supply it with 1 circuit breaker, and then, say, for instance, if only 1 vehicle is plugged in, then it gets the full power. And if both ports are occupied by 2 different vehicles, then maybe each vehicle will have half the amount of power. That's a good way to avoid expensive infrastructure costs. If, say, you're trying to install a lot of EVSE and you don't want to upgrade your service panel, you could eventually cut your system in half by doing some power sharing options. And that's a feature that's available in some EVSE. But then, as we discussed earlier, level 2 stations require 2 breaker positions. So for this, you'd want to plan out to make sure that there's 12 breaker positions available in each service panel that you're looking at.
I think we're down to just a little over 5 minutes left for this session. So if you want to just continue to, I think there is still item number 4 in the worksheet.
Yeah,
to
so
cover.
for the last step then, if there are any other questions, as mentioned, you have a 40 amp breaker size.
I'm sorry,
here.
I have not seen any more hands pop up yet. So I'm monitoring 2 different boxes here.
No problem at all. Yeah, so the last step, as we mentioned earlier, is sort of the construction plan. So you have EVSE all set out, you're going through this process, you know how much power you're going to need, what equipment you're going to need to install. The next step is really looking at the construction plan. So that'll be looking at planning out the conduit raceway, as it's referred to it, and where the wiring will go. You'll work with your electrician about making sure the wiring sizing is accurate and what you need, because wiring is a little bit of an art form in terms of selecting it. There's some guidance from the NEC you can definitely look towards, but it's somewhat dependent on the load and the length and the voltage. There's quite a few different elements in play here, and sometimes a trade-off between how thick of a gauge you want and potentially how much loss you want to, or you're willing to accept over the line. So sizing your wiring is sort of something you should definitely work with your electrician on. And then you want to make sure that you plan out what expansion of service panels or upgraded service panels you require here. So as we talked in the previous discussion there, looking at expanding that initial service panel and installing a new sub panel specifically for EVSE. And you'll just highlight, as mentioned, the conduit wiring and raceway and service panel upgrades. And then you can potentially have a great scope of the overall project that you can share with your utility and electrician and understand really what the impacts are, looking at before you even begin the procurement process for EVs or EVSE. After highlighting all of this, you can understand potentially if I'm going to be installing conduit along the walls here, if I have to trench, what would those costs look like, and planning out all of the different elements of construction and trying to consider all potential pathways. So you're making sure that you're installing this in the optimal way. You don't want to be installing a very expensive EVSE because it's very far away from your facility and then realizing that the payback period for that equipment is taking a very long time.
Great. And we did have a request to have you review load balancing. We think we kind of covered it already a little bit in that number 3, but if you want to review that a little bit with the group, that would be helpful.
Sure, yeah. So that came up, I think, in this particular site assessment. We touched on it in the previous portion of the session. We're talking about site assessment where this particular service panel in the top right here, the lighting load was about 150 amp lighting load. And when we looked through that, we realized that the majority of that lighting load was for the lights throughout the entire garage. So when most of the lights were turned on or during typical operations, the majority of those circuits were occupied. So therefore, if you're planning all of this out, you want to look at all the loads that are going to be consumed at a given point in time. So if you're going to be charging your devices during night, you might not need to consider having the lights on if people are going to be home and not using the garage. But if, say, they are going to be there whenever the lights would need to be on and the vehicles need to be charging, then you'll know that if the lighting load already occupies about 150 amps or so, then it's not going to leave a lot of spare capacity in there for new EVSE to be installed. And that's where you can see here, we then decided to upgrade the service panel to a 400 amp service panel and then feed each of those sub panels a separate lighting load, maintain that current panel at 150 amps, and then install a EVSE panel at 240 amps for all of the EVSE. And that's something that's really important to consider also. We didn't touch on this either, but there's the demand charge element. So a lot of it comes down to the peak demand, and that's like what we refer to as the maximum coincident demand. So think of coincident demand as all of the loads that are added up at any given time. So if you have 2 different lights that are each 10 watts, and then you have an EVSE, you'd add those 2 10 watts to the 20 watts of each light bulb, and then add that on top of the EVSE loads to say 7 kilowatts. So it'd be a little bit 7.02 kilowatts would be sort of the total coincident demand at any given time. And that's really what you need to consider is what is the worst case scenario coming through this service panel if I were to happen to have all the devices I want operating at once.
Double checking. I don't see anyone waving their hand or raising their hand. All right. Were there any other final statements you wanted to make before we wrap up this session, Jesse?
No, I think that covered it. Yeah, I hope that you all can walk through this worksheet on your own time, and it helps you in this planning process so you're more aware of the full scope of work that will be required for not only EV acquisition, but as well as EVSE installation and construction planning.
Thank you. Thank you so much for going through this. I know it's a lot for people to take in, and it often comes up, and I don't know how many discussions lately just because there was this great funding opportunity. So our hope for the attendees and whoever is able to watch the recording is that this is giving them the tools and information they need to move forward in their electric vehicle projects. So as a reminder, our next session is starting back to back, right? So there's no break in between this time, guys. But our next session will be starting immediately after this one. It is called Tools for Implementers, Data and Funding Resources. There will be a video of Jesse again, sharing some great information about an emissions tool. So to enter the next panel discussion, you will need to click on the unique meeting link listed under the session in the event agenda on the Whova platform. And yes, Kevin, all of this will be available on the Whova platform, so you'll be able to access it. So we will see you again here in just a couple minutes. Thank you.